Hello everyone. As you know, we are doing the P block element, and today we will do the halides of the P block element, and this is the lecture 4. Now here first of all we will discuss about what is the meaning of halides. Halides are the compounds of the halogen. When the P block elements or any element will react with the halogen, they will form their corresponding salts, and this is called the halides. Like if X2 is there, then it will be converted into 2X minus. Cl2, if it is react, it will form 2Cl minus. So halides like NCl3, like PCl3, like PCl5. So this is the meaning of the halide, like BiF5. So in which the halogens react with the element. This is called the halides, and they will contain the oxidation state -1. Now, as you know, during the P block element, we have done that there are two types of the oxidation states are possible for the elements, that is +3 and +5, and minus oxidation state is possible for the nitrogen. Now, in +3 oxidation state, they will form trihalide, and in +5 oxidation state, they will form pentaholide. You have already done, nitrogen has a tendency to form the trihalide, but not form the pentaholide. You know the reason well. In pentaholide, you are having like PCl5, you are having like BiF5, these type of the SbF5, these type of the compounds are possible in the pentaholide. Here, the oxidation state of the central atom is +5, and the oxidation state of central atom in trihalide is +3. Now you can easily understand regarding the stability of trihalide and pentaholide. Yes, which one is more stable? Yes, you are very much correct that pentahalides are less stable as compared to trihalide, because as you are moving down the group, the inert pair effect will come in consideration. Because of that reason, inert pair effect, the stability of +5 oxidation state decreases, and the stability of +3 oxidation state will be increases. So whenever we are comparing PCl3 and PCl5, the PCl3 is more stable as compared to PCl5, and the PCl5 can be easily decomposed. When we are heating the PCl5, we will get PCl3 and Cl2. This kind of the reaction will shows that they can be decomposed easily. Now, when we are looking for the trihalide and pentaholide, one more thing we have to discuss, we should know about the type of bond present between them. Like pentahalides are more covalent in nature as compared to trihalide. Now see what is the reason behind it. And in the lecture 1, 2 or 3, we have discussed about the Fezan's rule. During this rule, according to this rule, smaller the size of the cation. Like if you are having phosphorus in +5 oxidation state and phosphorus in +3 oxidation state, this will have the high polarizing power. And because of that reason, it will polarize, it will disperse the negative charge of the Cl-. So, whenever the dispersion of the negative charge will take place, this will be the polarizing power of P +5. So, the PCl5 will be more covalent in nature as compared to PCl3. This is very important question. Why the PCl3 is less covalent and more ionic in nature as compared to PCl5. Now we will concentrate on the trihalides and pentahalides. So first of all, we will see about the trihalides. Trihalides are, most of them are Lewis acid. Lewis acid, you know well, they has a tendency to accept a pair of electron, and they has a tendency to react with the bases. You may see the example of, like if you are having PF3, when it is react with F2, it will gives formation of PF5. Now suppose you are having SbF3 and it will react with the Lewis base, it results in the formation of SbF5 with 2 negative charge. Such kind of the reaction will shows that trihalides are Lewis acidic in nature. Now, if we will see the structures of the trihalides, like if you are having PCl3 or you are having NCl3, you can easily form the structure as the phosphorus has the 5 valence electrons. So there is 1 lone pair of electron, and the 3 chloride ions are present in this manner. hybridization will become sp3 and it has the pyramidal shape, which is very important for the MCQ point of view for the assertion and reasoning questions. Likewise, you can prepare the structure of NCl3. All are having the same structure, that is hybridization is sp3 and pyramidal shape. Only the difference in their bond angles, otherwise the shape and the hybridization will remain the same. Now, the PCl3 will undergoes in the hydrolysis and reaction with the water, that is 3H2O. It will give rise to the formation of H3PO3 plus 3HCl. Now see how this reaction will be utilized in a reactions, in a questions. In MCQ, it may be asked that what happens when PCl5 will be get moisture. Then you will say that there is a formation of white fumes of HCl. Formation of white fumes of HCl causes the formed during the hydrolysis of this PCl3. तो जब हम इसको moist air में रखते हैं तो HCl formation होता है और white fumes निकलती हैं and there is a formation of oxo acid of the phosphorus H3PO3. Now let us consider for the PCl5 or the pentahalide. If you are looking for the PCl5 will have the, now see here, the PCl5 will have this kind of the structure that you have done in the 11th standard also. That is a trigonal bipyramidal shape with the hybridization sp3d. Now here these two bonds are the axial bonds and these bonds are having the 90-degree bond angle and these are the trigonal bipyramidal and they are having the bond angle 120-degree. So this question may be asked, how many axial bonds are there in pentahalides? So the answer will be 2. And how many equatorial bonds are there in pentahalide? Then you will say it is 3. So these two MCQ questions can be asked. Geometry can be asked. Hybridization can be asked. So now, if the two bond angles are of different magnitude, then we will see how does they will affect the stability of these bonds. These two PCl bonds, axial bonds are more elongated. They are not equivalent. Means they don't have the same bond length. इन दोनों की bond length same होगी और इन तीनों की bond length same होगी. But they are having the different bond lengths because these are axial and they are lying at the 90-degree bond angle. So there is a more repulsion, more bond pair repulsion, which causes the elongation of this bond than expected. And as compared to the equatorial bonds, because these are lying at the 120-degree bond angle. And because of that reason, whenever the reaction will take place, suppose the PCl5, as we have done, अभी recently मैंने आपको बताया है कि PCl5 is less stable because the +5 oxidation state is there, and due to inert pair effect, the stability of +5 oxidation state is less. So it will give rise to the formation of PCl3 and Cl2. ये जो दो Cl2 निकले हैं, these are the axial bonds के पहले निकलेंगे because they are having the large bond length. Similarly, if we are taking the PCl5 product of hydrolysis will be the POCl3 and there is a formation of POCl3 and there is a formation of white fumes again because of the generation of HCl that already happened in PCl3. So you have to be remember, whatever it is trihalide or the pentahalide, whenever the hydrolysis will carried out, the white fumes are formed and it is due to the generation of HCl. And POCl3 on reaction with 3H2O, it will give rise to the formation of oxo acid of phosphorus and the HCl generation. ये जो पहले दो Cl निकले हैं, these are of axial. So these two equations justify that all the bonds in PCl5 are not equivalent due to the different bond angles and they have repulsion between the bond pairs. Axial bonds are more elongated and reactive than equatorial bonds. These are more elongated and reactive. The another MCQ question can be asked or assertion reasoning question can be asked from this topic. The one more important question is that PCl5 is exists as an ionic solid and it has a very high melting point. Very high melting point. It is because of the reason that PCl5 in the solid state will exist as an anion and cation. And you know well, whenever the anion and cations are there, they are having the strong electrostatic force of attraction between them. And because of that reason, they have the high melting point because of the strong force of attraction between their cation and anion. Yes, now we will discuss about the next is N2. You have done the lots of questions regarding the N2. N2 is the dinitrogen, that is a nitrogen gas. It exists in the form of two isotopes. Nitrogen is exist in the two stable isotopes, that is a nitrogen N14 and N15. It is colorless, odorless, and tasteless gas. It is a non-toxic gas. It has a it is highly unreactive. It is inert at the room temperature. Lots of questions you have done. That is, it has the structures N triple bond N, linear structure, high bond dissociation energy. It can create the inert atmosphere. Means we can, whenever we need the inert atmosphere, we can use the N2 gas. It is neutral because it has no action on the red litmus paper or the blue litmus paper. When the nitrogen is directly react with the metals like lithium, magnesium, calcium, or aluminium, it will forms their corresponding nitride. Nitrides are the compound of the nitrogen in which the nitrogen is exist in -3 oxidation state. Like when they react with the lithium, it will results in the formation of Li3N, that is lithium nitride. With the magnesium, it will forms Mg3N2, magnesium nitride. Likewise, you can form for the calcium and aluminium. So you have to draw how the nitride of calcium and the aluminium will be formed on reaction with N2. So you may write all the 4 reactions by yourself. So now the N2 will be react with the hydrogen. This is the most important use of the dinitrogen. When it is react with the N2, it will result in the formation of ammonia gas. Ammonia gas is formed by the Haber process. In Haber process, we will use, there is a equilibrium sign will be exist between them, and the temperature used will be 700 Kelvin and the pressure will be 200 atm, or you can convert this into Pascal, that is 200 into 10 to the power 5 Pascal. So these two are the conditions जो आपको पूछी जा सकती हैं in MCQ और assertion reasoning में कि how does, what is the maximum, what is the conditions at which we are getting the maximum yield of ammonia, and it is a use of N2 also. This reaction can be utilized in the preparation of ammonia. NH3 की preparation में भी use कर सकते हैं. Here we will use the catalyst as a iron is used as a catalyst here, and we will use promoter as MO. So this is the repeated topic we will do in the ammonia topic. Now, this is the use of ammonia here which we are doing. Apart from this, the N2 can also be used in the formation in the refrigerant, used as a refrigerant to preserve the biological specimens, in freezing the foodstuffs, and also in cryosurgery. It is also used in the thermometers for measuring the very high temperature. उसके अंदर भी इसको हम use कर सकते हैं. Now, after that, we can do the dinitrogen की इसके अंदर आपका formation of from azide. कि azide आपका ये है. This is the reaction with the sodium. There is a formation of azide, NaN3. तो NaN3 में azide क्या होते हैं? एक होते हैं nitride और एक होते हैं azide. अभी हमने nitride किया. Nitride is N with 3 negative charge. ये nitride है. But whenever we are having azide, azide is N3 with 1 negative charge. See the difference. So MCQ question can be asked in this manner also. So whenever you want to be react the nitrogen with sodium metal या barium, they will rise to the formation of nitride, azide, not the nitride. यहाँ पर nitride नहीं बनेगा. Nitride will be formed only when the metal is strong reducing agent only. वो तभी बनता है आपका. तो azide में अगर आप लेते हैं, अगर आपने azide को heat किया, suppose you are having NaN3 and you are heating it. और जब आप इसको heat करते हैं, so there is a formation of sodium metal and the formation of nitrogen gas. तो nitrogen gas will be evolved. This is a decomposition of azide. तो इस reaction के अंदर ये भी पूछा जा सकता है कि azide अगर कैसे बन रहे हैं, azide के ऊपर charge क्या है, azide कहते किसे हैं. So this is the topic related to the आपका जो हमने भी nitrogen किया है, dinitrogen N2. Now we will see a very short topic of the ammonia because most of the topic we have covered for the ammonia in hydride also. So quickly we will do this topic also. So now here this I have done. I have told you कि how can you prepare, how can you use the N2. N2 को आप कैसे use कर सकते हैं for the formation of ammonia. Then properties we have done. It is a good Lewis base because it has a lone pair of electrons. एंड वाटर के साथ अगर हम इसकी रिएक्शन करते हैं तो इट विल गिव्स ए वेरी वीक बेस. NH4OH is a very weak base because whenever you will dissociate it, you will get in the equilibrium position, reversible reaction. So ammonium hydroxide, it is a weak base. It is a good complexing agent that we have done in the hydride topic. K electron, lone pair of electrons are there. On reaction with copper, there is a formation of complex of copper. With Ag+, it will give rise to the formation of the complex of silver. It is liquid at the room temperature, again due to the hydrogen bonding. It has the high melting boiling point because of the hydrogen bonding. Soluble, AgCl is soluble in water because there is a formation of this soluble complex. So up to here we have completed the आपका जो हमने किया nitrogen topic, ammonia and the halides related to the p block element. So till then you have to watch all the lectures carefully, lecture 1, 2, 3 and 4, and then make your proper notes with the questions and ask your doubts. Till then, complete your work.